delay there. There were some technical issues. Thanks everybody for coming to Space Expo. I hope you're all having a really good time. My name is Aidan Flanagan. I'm a postgrad student here in Trinity College. You might recognise me from the comet workshops that we do here every day at 5. And if you don't, stick around because right after this we're going to do another comet workshop today. Today I'm going to be talking about something a little bit further out. I'm going to talk about interstellar spaceflight. So that is travelling between stars, or more interestingly, travelling from this star to another star. And it's an interesting topic because in science fiction we're very used to the idea of our heroes and our characters travelling from one star to the other. They normally do it very, very quickly and very easily. They can do it through the use of kind of powerful engines on starships, or even through kind of wormholes in space and time. And again, they make it kind of commonplace that in the future humanity will have interstellar travel, and it'll be something that will be very easy and quick. But it makes me wonder, will humanity ever actually visit another star? Is this something that is going to remain just within science fiction, or is it something that we can eventually see as a reality? So if Joe helps me by going to our movie now, which is the reason we were late, we can start to see the distances we're talking about here. So as we zoom in on the sun, this is our star, and you can slowly zoom out and begin to see our local planet. So this is just the rocky kind of Mercury, Venus, Earth, which is us, and as we zoom out further, we see the gas giants. So this is the orbits around the sun: Jupiter, Saturn, Uranus, and Neptune. Unfortunately, no Pluto. So as we travel out further and further, we start to see that in interstellar space, there's not a lot going on. It's only when we get out to about 1 light year that we see the Oort cloud, which is where we get our comets and our meteorites. And then finally, when we're at about 4 or 5 light years away, we finally start to see nearby stars. And as we pan around, we can get an idea of where these are located relative to the Sun. And it's this star just beneath the Sun in this image, Proxima Centauri, which is the closest star. So that's 4.24 light years away. Now, does anybody know what a light year is? Yeah, go ahead. Yeah, good job. So it's how long light gets after 1 year of travel. And light is very, 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 very fast. So the speed of light is about 300,000 kilometers per second. So that means in 1 second only, it can travel around the Earth 7.5 times. So it's very fast. And you can imagine that in 1 year, it can go obviously a much, much greater distance that's difficult to comprehend. So if you want to put a number on it, a light year is about 10 quadrillion kilometers. So just a stupidly large number, or 10,000 billion kilometers. So going 4.25 light years is no easy task. It's going to take a huge amount of effort and time and engineering. But it's good to see where we've gotten so far. So the furthest we've gotten in man, or close to the furthest we've gotten in astronauts, is occurred during the Apollo 11 mission. And in that mission, we successfully landed a couple of astronauts on the moon, which is about 380,000 light years away from Earth. And that's fairly impressive. And it's not even the furthest we've gotten anymore. In the Apollo 13 mission, we had astronauts going around the far side of the moon. So they actually got to about 400,000 kilometers away. And that's a huge feat of engineering and technology, but it's nothing compared to the quadrillions of kilometers we need to travel for interstellar flight. So we kind of need to turn to unmanned missions in terms of interstellar travel. So the record holder for the furthest man-made object, unmanned man-made object, is Voyager 1. So this is an instrument that was sent into space in 1977. And since then, it's been the mission of Voyager was to pass by a number of planets and take very high-resolution images and send them back to the Earth. But there was a secondary goal of carrying on into interstellar space, the space in between the stars, and getting some readings of that. Now, it was sent in 1977, and ever since it's been traveling at about 17 kilometers per second, which is outrageously fast. But despite the fact that it's been traveling for that long, it's only now getting into the interstellar medium. We're starting to see results that suggest that it's outside of the solar system. And that's at a distance of about 18 billion kilometers away, which again is very, very impressive, but it's still a fraction of a percentage of the distance of the nearest star. So if we pointed Voyager 1 at Proxima Centauri, our nearest star, it would get there in a quick 75,000 years. So that's too long for me to wait. I don't know about you guys. So we need to start thinking about some slightly faster technologies. Now, one idea is the idea of a solar sail. So this is kind of a space sailboat which uses light from the sun to accelerate it forwards. As it reflects sunlight back towards the sun, this in return kind of pushes the solar cell out of the solar system. And we think that we can get it up to about 20 kilometers per second. So just a little bit faster than Voyager 1. But still, it would take 57,000 years to get to the next nearest star. So again, that's too long, too boring. So we need to bring in the big guns. This is an artist representation of Project Orion, which nearly works kind of like a normal rocket. A rocket is essentially just a tube full of fuel, which burns fuel at one end, causing an explosion and propelling the rocket forward. But Project Orion is like that, but instead of using chemical explosives, it uses nuclear explosives. So at the bottom of the ship there, it's actually setting off small nukes over and over again to propel it forward. It's called nuclear propulsion. Now this can get the ship to travel at alarming speeds, tens of thousands of kilometers per second. So thousands of times the velocity of Voyager and the solar sailboat. But the downside is when you're going this fast, if you hit even a speck of dust in interstellar space, because of the huge relative velocity, the energy is comparable to being hit by a small nuke. So you need to have a very good shielding system in front of the ship. So if we send this ship towards Proxima Centauri, we'll get there in 100 years, which is much, much better. It's getting much closer to a human lifetime. And if we stretch our imaginations even further, we can consider the Alcubierre drive, which I hope I'm pronouncing correctly. But this drive was developed by Miguel Alcubierre, a Mexican theoretical physicist, and he showed that it's mathematically consistent with our understanding of the universe to have a ship which basically has a warp drive. So instead of propelling itself forward by any simple means, it actually changes the properties of space around it. It compresses space in front of the ship and expands it behind the ship. And this allows it to travel at unbelievable speeds. And while all of our other ships so far were limited by the speed of light, no ship that we can build can go faster than the speed of light. This ship in fact could, because it's not actually propelling itself in a simple way, it's actually altering the space around it. So given that, it could get to Proxima Centauri in 4 years or less. But the only small downside with this ship is that the energy required to power the engine is more energy than we know to exist in the universe. So that's just a little too much for us to be able to afford right now. So you can start to see that as time goes on, we develop faster and faster technologies, or faster and faster starships. And you start to think, at what point is it a good idea to actually send up a mission? Because if we send a mission now, that takes 75,000 years to get to the next nearest star. In 10 years, we could send a much faster ship which just overtakes it and renders the first ship useless. And it's especially bad if there's astronauts on that first ship, and you look out the window and see, and then they're on year 10,000 of their mission, and you look out the window and you see a super-powered rocket ship fly by them faster than the speed of light. It's just a little bit too depressing. So the calculation you need to do here is called a weight calculation. And what it says is, how long do we have to wait before it makes sense to start sending off these missions to get to the nearest star? And a guy called Andrew Kennedy, a few years ago, published a paper where he calculated this, and it's about 1,111 years. So we're back to depressingly long amounts of time. I don't want to wait 1,111 years. But this isn't the final stage of this kind of research. There's projects such as Project Icarus, which is just starting now, basically. It only started in 2009. And they aim to get a starship on another star in the next 100 years. They're much more ambitious than Mr. Kennedy. And it's projects like the Icarus Interstellar Program and the 100-year Starship Program, both of which are aiming to get on other stars in 100 years, which just completely ignore this 1,000-year goal. So if you're a person who's enthusiastic about science and about interstellar travel, or if you're a physics student who thinks that this is unreasonable or unobtainable, think again. Now is the time to get involved with this kind of research. Thank you.